In this module, we will learn about Docker Universal Control Plane. It allows the management of images, applications, networks, and other computing resources on multiple Docker hosts for a centralized place. We will do a brief introduction followed by the lab activity of deploying UCP and managing the infrastructure through it. Role-based access control is an important and useful feature of UCP. We will go through it. We will also cover the LDAP integration, UCP client bundles, and usage of external certificates on UCP. All of this are important from the certification examination point of view. So let's get started. Hello everyone. Docker Universal Control Plane (UCP) is the enterprise-grade cluster management solution from Docker. It is a containerized application that runs on Docker Enterprise Edition or DEE. Extended its functionality to simplify the deployment, configuration, and monitoring of your applications at scale. UCP also secures Docker with role-based access control so that only authorized users can make changes and deploy applications to your Docker cluster. We can install it on-premise based on deployments or in cloud-based deployments. As I mentioned earlier, it provides a single interface graphical UI to manage the cluster and the applications running on it. We can join up to thousands of physical or virtual machines together to create a container cluster that allows us to deploy the applications at scale. With the latest version of Docker Enterprise Edition, UCP works both with swarms as well as Kubernetes. While installing UCP, if nodes are not already running in swarm, then the nodes will be configured to run in swarm mode. Hello everyone. In this nugget, we will look at the prerequisites for installing UCP. And it is to have Docker Enterprise Edition installed on the host. Docker provides a 1-month trial period for Docker Enterprise Edition, so you can make use of it for the examination practice. On my test bed, I have 3 Docker hosts ready with Docker EE already installed. They are not yet in the swarm. I will configure one of them as manager and the other 2 as worker nodes. So UCP runs as a container on the manager node. I will run the command. It runs the container with name as UCP, configured a volume to provide access to the var run docker sock of the Docker host inside the UCP container. Provided the UCP image is 316 with commands as install, run the command in the interactive mode. Here I have not specified the IP address, but if you have more than one network interface, then you should provide the IP address as well. Okay. So it errors out saying that it doesn't have enough memory. So we can proceed by specifying the force minimum flag. So let's do that. Okay. It will provide the admin username as Wizlabs and give the password. Okay. Now it will take a few minutes for the installation. So it is pulling the various images required for the UCP installation. It has initialized a new swarm at these IP addresses. Since we have a cloud-based deployment, hence the IP address mentioned here is the internal IP address. It is now deploying the UCP service, for which it will take a few minutes or so. Okay, so we can see that the installation is now complete. We can access the UCP over the browser. So log in with the credential provided at the time of installation. So let's go to the browser. Okay, so click on this. We will log in with the credentials provided at the time of installation. So let's provide that. It will ask for the license for the Docker EE, so which I will upload. Okay, so login is successful and we can see that there is one manager node at this time which is in ready state. Okay, this is the same machine on which we installed UCP. The tokens required by the other nodes to join this swarm as worker or manager are mentioned over here. So under shared resources, we can go to node. Right now, there is only one node in the swarm. Okay. From here, we can add more nodes. So since latest version of UCP supports Kubernetes, we have the option of changing the orchestrator type. So right now, the default is swarm. For the certification point of view, we need to focus on swarm only. The node that we want to add to the swarm is running Linux and want to join as a worker. So we need to run the following command on the nodes to add them to the swarm. So we are on the worker 1 node. So let's run the command. Okay, so we can see the message that this node has joined the swarm as a worker. Similarly, let's add the other node as the worker to the swarm. And this node also joins the swarm as a worker. Now let's go back to our UCP UI page. There are 3 nodes listed out here, as you can see. Right? Now manager is healthy, worker 2 is pending configuration, and worker 1 is awaiting healthy status. It will take a minute or so to get in the healthy state. So now worker 1 has become healthy. And now both the worker nodes are in healthy state, as we can see. Right? If we go to the dashboard now, we can see that there is one manager node and 2 worker nodes in the ready state. When we deploy UCP, it starts running a globally scheduled service called UCP-agent. This service monitors the node where it's running and starts and stops UCP services based on whether the node is a manager or a worker node. The UCP-agent accomplishes this by deploying several containers on the node. Now let's check the containers running on the manager and worker nodes. So we are on the manager node now. Clear it a bit. So I want to check the running containers on the manager node here. So this, okay, let's do the ps and format. So this lists the list of containers which are running on the manager nodes. Now similarly, let's check on the worker node. Okay, so let's run it there. And we can see there that only a few containers are running here compared to the manager node. On the manager node, the UCP-agent service automatically starts serving all the UCP components, including the UCP web UI and data stores used by the UCP. By promoting a node to manager, UCP automatically becomes highly available and fault tolerant. Whereas on the worker node, the UCP-agent service starts serving a proxy service that ensures only authorized users and other UCP services can run Docker commands in that node. The UCP-agent deploys a subset of containers on the worker nodes. Once UCP instance is deployed, developers and IT operations no longer interact with the Docker engine directly, but interact with UCP instead. Since UCP exposes the standard Docker API, this is all done transparently. Hello everyone. In this nugget, we will discuss about role-based access control. Docker UCP has its own built-in authentication mechanism and role-based access control, that is RBAC, so that you can control who can access and make changes to your cluster and applications. UCP lets you authorize users to view, edit, and use cluster resources by granting role-based permissions against resource sets. To authorize access to cluster resources across your organization, UCP administrators might take the following high-level steps. First is to add and configure subjects. A subject represents a user, a team, organization, or service account. A subject can be granted a role that defines permitted operations against one or more resource sets. When subject is a user, it is in person authenticated by the authentication backend. Users can belong to one or more teams or one or more organization. Team is a group of users that share permissions defined at the team level. A team can be one organization only. An organization is the group of teams that share a specific set of permissions defined by the roles of the organization. Now let's go to the UCP in our test lab. There is a section of access control. So let's expand it, and there we can see the organizations and teams, users, roles, and grants. First, we will check the organizations and teams. By default, this organization is created. So let's create one more organization. Let's call it Finance. Okay. I will have to create team. So it got created. I can add users. So right now there is only one user, which is the admin user. So let's call it as a test account 1 and a password. I will add this user to the finance controller team. We can make this user as the admin user, but let's skip that for now. Once the user, okay, and let's say create. Now, once the user is created, let's go back to our team. Now I want to add the user in the controller team. So select test account 1 user, which is created just now. The user got added successfully. If I go to the users and click on test account 1, okay, so I can see the team membership as well here. So he is the member of one team only. Next step is to define custom roles by adding permitted operations per the type of resources. Roles define what operations can be done by whom. A role is a set of permitted operations against a type of resource, like a container or volume, that's assigned to a user or team with a grant. For example, the built-in role restricted control includes permission to view and schedule nodes, but not to update the nodes. So let's get back to the roles, and we will focus on these roles. We have 4 built-in roles already created. So let me create one more. Let's call it as control 1. Let me select the operations for this role. Okay, let's select it, and we can see that the role got created now. Next is the group instance resources into resource set of swarm collections or Kubernetes namespaces. In order to control user access, cluster resources are grouped into Docker swarm collections or Kubernetes namespaces. Next, now is to create grants by combining subject, roles, and resource sets. So grant define which user can access what resources in that way. Only an administrator can manage grants, subject, roles, and access to resources. Now let's create a grant on our deployment. We can select the users or the organization. Okay, users or the organization. In the users, we have the users which we created. So if I go to organization, I can select the organization. So let's select finance. For team, let's say controller. Click on next to resources. Let's stick to swarm collections. For roles, I will select the role which we created, Control 1, and say create. So we have provided the grant to the team controller. Let me now log out and log in as the test account 1 user. So we are logged in as the test account 1 user now. We can see that the login is successful. If I go to profile for this user, I can see the grants allocated to it. Hello everyone. We can also configure LDAP in the UCP. Let me log in as the admin user here and click on admin settings under the your username and drop down. Click authentication and authorization. Scroll down and click yes for LDAP enabled. A list of LDAP setting will be displayed. Input value to match your LDAP server installation. And once the values are added, then test your configuration in UCP. And then you can initiate the sync. Click sync now to initiate LDAP sync operation immediately after the configuration of the team. It may take a moment before the members of the team are fully synced. Hello everyone. In this nugget, we will learn the UCP client bundles. There are two ways to interact with the UCP, the Web UI and the CLI. What we have seen so far that you can use the UCP Web UI to manage the swarm, grant and revoke user permissions, deploy, configure, manage and monitor your applications. In addition to the Web UI, UCP also exposes the standard Docker API. So you can continue using existing tools like the Docker CLI client. Since UCP is secured, we need to configure the Docker CLI client and the other client tools to authenticate the request using client certificate. We just need to download a user UCP client bundle. A client bundle contains a private and public key pair that authorizes the request in UCP. So let's get back to our UCP. And we will log in as a test account we created earlier. I'll click on the username on the left and go to my profile section. Here there is an option client bundles and we will generate a new client bundle. Let us access the contents of this downloaded zip file. Here we can see that the client bundle contains the public and the private key pair. It also contains the utility scripts that you can use to configure your Docker and kubectl client tools to talk to your UCP deployment. The client bundle utility scripts update the environment variables Docker host to make your client tools communicate with the UCP deployment. To use the client certificate that are included in the client bundle you just downloaded. UCP issues different kinds of certificate depending on the user. User certificate bundles only allow running Docker commands through the UCP manager node, whereas admin users certificate bundles allow running Docker commands on the Docker engine of any node. And it also updates the Docker certification path and environment variable. Hello everyone. In this nugget, we will learn about UCP security. Universal Control Plane is configured to be secured by default. It uses two certificate authorities. One, CA, is used for all internal communication between managers and workers. The use of mutual TLS is automatic between the managers and the worker nodes. Mutual TLS or MTLS is where both the client and the server verify the identity of each other. The second CA is for the end user communication. Two communication paths are vital to keeping the traffic segregated. While adding a worker node, we know that a join token is used. The token itself incorporates the checksum of the CA certificate for communication with the manager node. We can customize UCP to use certificates signed by the external certificate authority. These certificates are used instead of the ones generated by the client root CA. That way, you can use a certificate for a CA that your browser and the client tools already trust. So let's go back to the browser. We need to log in as an admin to the UCP. To add an external certificate, we go to admin, within that admin settings, and then choose certificate. We can add the CA certificate, UCP instance certificate and private key. Using the external certificates is a good option when integrating with the corporate environment. Using external officially signed certificates simplifies having to distribute certificate authority certificates. Hello everyone and welcome to the 10th module of the Docker course. Till now in this course we have used the Docker Hub as the registry for storing the images. In this section we will deploy our own registry, configure it and access it through a Docker engine. In addition, we will also take a look at the backup process for the Swarm, UCP and the Docker Trusted Registry. We will cover some miscellaneous topics like garbage collection, configuring external certificates with DTR, storage backend, accessing health of DTR and network used. Hello everyone. In this nugget, we will talk about deploying registry. Docker Trusted Registry or DTR is the enterprise-grade image storage solution for Docker. Docker UCP integrates with Docker Trusted Registry. DTR is generally installed behind the firewall so that we can securely store and manage the Docker images we use in our applications. We can also enforce security policies and only allow running applications that use Docker images we know and trust. DTR has a user interface that allows authorized users in your organization to browse Docker images and review repository events. DTR is highly available through the use of multiple replicas of all containers and metadata such that if a machine fails, DTR continues to operate and can be repaired. DTR uses the same authentication mechanism as Docker Universal Control Plane. Users can be managed manually or synchronized from LDAP or Active Directory. DTR uses role-based access control, also known as RBAC, to allow you to implement fine-grained access control policies for your Docker images. DTR is a containerized application that runs on a Docker Universal Control Plane cluster. It needs to be installed on a worker node that is being managed by UCP. You cannot install DTR on a standalone Docker engine. Docker Trusted Registry can be installed on premises or on the cloud. All nodes installing DTR should be worker nodes managed by UCP, that is Universal Control Plane. Recommended production environments for the nodes are 16 GB of RAM, 4 vCPUs and virtual CPUs, and 25 to 100 GB of free disk space. DTR uses port 80 and 443 of TCP for web applications and API client access. Now let's navigate to the UCP web UI and log in as an admin user. In the admin settings, choose Docker Trusted Registry. It says that the UCP cluster doesn't have the DTR installed yet. So I will select the node on which I want to install DTR. I want to install it on the worker node worker 1. Okay. And I will disable the TLS certification for this installation. In production, this would always be enabled since I don't have DNS resolvable names for the nodes. I have added the entries in the etc host file of the nodes. We will run the commands to install DTR and run it on the target node. Worker 1 is the UCP node where we want to install the DTR. So UCP username is Wizlabs, so which is the admin user. Okay, now let's run the command. It will ask for the UCP password. Okay, so now okay, so and as you can see, it has created the DTR registry now. Okay, you can see all of these things being getting created, and now the installation is complete. Now back to our browser, navigate to the Docker Universal Control Plane web interface and navigate to Share Resources, Stacks. DTR is listed as an application. Log into DTR by accessing it from the browser. So let's go here. Okay. It says welcome to Docker Trusted Registry. Provide the same certificate credentials as UCP. You can see that the login is successful and we don't have any repositories as of now. So let's create a new repository. The user repository for the WizLabs user, let's make it for the Nginx. Give some description, configure this to be visible to everyone and create. I will push the images from the worker2 node of my UCP cluster. Okay, so I'm on the worker2 node. I will first pull the Nginx image. Download is complete. I will tag the image as the IP address of our DTR. Okay, so we see that the tagging is complete. If we try to push the image, let's see what happens now. So I will use the command docker push and okay, let's try. So we get this error message to the resource is denied. So let's log into the first DTR first using Docker login. Provide the username and password. Okay, and the login is succeeded. Now push the image and see what happens. So let's do that once again. It's doing it. Now let's access this repository. Okay, let's access this repository. Now let's go back to our DTR web UI. Let's access this repository, and now we can see that there is only one image which is uploaded. In the similar fashion, we can upload more images or pull them from the registry. Let's try to pull this image from the manager node. Let's log in first to the registry. Okay, and now we can do the Docker pull. So pull succeeded. Now if I do Docker ls, we see that the image is available here. So just like we pull the images from the Docker hub, we can pull the images from the local registry as well. Hello everyone. In this nugget, we will talk about backups and disaster recovery. We take backup of our Docker components in the following order. First, we take backup of your swarm, then backup UCP, and finally backup the DTR. First, we will talk about the backup of the swarm. Docker manager nodes store the swarm state and manager logs in the /var/lib/docker swarm directory. This data also includes the keys used for encrypt the raft logs. Without these keys, you cannot restore the swarm. You can back up the swarm using any manager using the following procedure. If the swarm has auto lock enabled, you need the unlock key to restore the swarm from backup. Retrieve the unlock key if necessary and store it in the safe location. Stop Docker on the manager before backing up the data so that no data is being changed during the backup. Backup the entire var lib docker swarm directory. Restart the manager. Let's look at the backup for the UCP. To create a UCP backup, we run the docker/UCP backup command on a single UCP manager. This command creates a tar archive with the content of all the volumes used by the UCP to persist data and streams it to std out. The backup doesn't include the swarm node state like service definition and overlay network definition. You only need to run the backup commands on a single UCP manager node. Since UCP stores the same data on all manager nodes, you only need to take the periodic backups of the single manager node. UCP restore recovers the following assets from the backup file: users, teams, and permissions. All UCP configuration options available under the admin settings like the Docker EE subscription license, scheduling options, content trust, and authentication backends. Let's see how to backup the DTR. Docker Trusted Registry of DTR is a clustered application. You can join multiple replicas for high availability. For a DTR cluster to be healthy, a majority of its replicas, that is n by 2 plus 1, need to be healthy and be able to communicate with the other replicas. This is also known as maintaining quorum. This means that there are 3 failure scenarios possible. The first is replica is unhealthy but cluster maintains quorum. One or more replicas are unhealthy, but the overall majority, that is n by 2 plus 1, is still healthy and able to communicate with one another. Second is the majority of replicas are unhealthy. A majority of replicas are unhealthy, making the cluster lose quorum, but at least one replica is still healthy, or at least the data volumes of DTR are accessible from that replica. The third is that all replicas are unhealthy. This is a total disaster scenario where all the DTR replicas were lost, causing the data volumes for all DTR replicas to get corrupted or lost. To perform a backup of the DTR node, we run the docker DTR backup command. This command backs up the following data: the configurations, repository metadata, access control to repos and images, notary data, scan results, and certificates and keys. The image content needs to be stored separately. Users, orgs, and teams are backed up as part of the UCP. In this nugget, we will go through some miscellaneous topics on DTR which are important from the exam point of view. First is DTR security. Docker Trusted Registry continues the Secure by Default theme with 2 new strong features: image signing via the Notary project and image scanning. Additionally, DTR shares authentication with UCP, which simplifies setup and provides strong role-based access control, that is RBAC, without any effort. DTR stores metadata and layer data in 2 separate locations. The metadata for the images is stored locally in a database that is shared between replicas, and the layer data is stored in a configurable location, which we will just see in this module only. We will cover the image signing and scanning as part of the next module. External certificates. Just as with the UCP, DTR can use fully signed company certificates or self-signed certificates. The certificate authority CA for the organization can be used. So let's go back to your web UI for the DTR to see how to configure the external certificates. Go to System, General, and then Domain and Proxies. Click on Show TLS Settings. This is where we can add the root CA or change the instance certificate for the DTR. Now let's see storage backend. By default, DTR uses the local file system of the node where it is running to store the Docker images. You can configure DTR to use an external storage backend for improved performance or high availability. DTR supports the following storage systems. For local file systems, we can use NFS, bind mounts, and volumes. And for cloud storage providers, we can have Amazon S3, Microsoft Azure, OpenStack Swift, and Google Cloud Storage. The choice of the storage backend for DTR has effects on both the performance and security. So let's go to the DTR web interface and see how to configure the storage backend. Navigate to System and then Storage. And here we can configure whether we want the local storage system or cloud. If you take local, then we can use these options. And if you take cloud, then we have the Amazon S3, Azure, Swift, and Google Cloud Storage. Now, next topic is the garbage collection. Old out-of-date images may contain security flaws or exploitable vulnerabilities. So removing unnecessary images is important. Garbage collection is a feature that ensures that unreferenced images and layers are removed. You can configure the Docker Trusted Registry to automatically delete unused image layers, thus saving your disk space. With the latest version of Docker EE, the registry no longer has to be in read-only mode or offline during garbage collection. Select for how long the garbage collection job should run. First is until done, which means run the job until all unused image layers are deleted. For X minutes, only run the garbage collection job for a maximum of X minutes at a time. And never, which means it deletes unused image layers. Now let's go to the web interface. To schedule the current garbage collection, navigate to Settings and Garbage Collection. As we discussed, there are three options available: until done, for X minutes, or never. If I select until done or for a specified number of minutes, we can also schedule the garbage collection, and then we can save and start. Okay. Now, garbage collection job logs can be accessed under the system job logs. Now, next topic is about networks used by Docker Trusted Registry. Network with name as DTR-OL and type as overlay allows DTR components running on different nodes to communicate to replicate DTR data. Let's go to our DTR node, which is worker 1 node. Let me clear the screen a bit. I will check the networks configured on this node. So there is a network with DTR-OL and types as overlay. So let's look at how to monitor DTR replicas. Under the tags page of the UCP, all the DTR replicas are displayed. I am on the UCP page now, and if I go to tags, all the DTR replicas will be listed here. Now there is one DTR in my deployment. DTR also exposes several endpoints you can use to access if a DTR replica is healthy or not. First is /_ping. Checks if the DTR replica is healthy and returns a single JSON response. This is useful for load balancing or other automated health check tasks. Next is the Nginx status, returns the number of connections being handled by the Nginx frontend used by the DTR. And last is the /API/v0 meta cluster status. This returns extensive information about all DTR replicas. There are two arrays in its results: current issues and replica health, which provides the health status. So in this section, we covered the security, external certificate, storage backend, and network garbage collection monitoring of DTR replicas.